Welcome back to another video tutorial. Today I've got a Milwaukee work radio here. It's 240 volt radio. The problem is it doesn't turn on, so I'll just plug it in and give it a bit of a quick test here. I've got nothing, so it doesn't turn on, so hopefully we can be able to fix this one. So we don't know what we're going to find until we pull this one apart, so we'll drop it out and we'll go through the process on how we find the fault in this Milwaukee radio. No power. Back shortly. Okay, I'm back with this Milwaukee radio. Someone's had a look at it before me. Anyway, what I've done, I've taken the side handles off. All the screws off side handles, which allows me to pull this front section out. But when I look inside, already this is floating around. Someone hasn't bothered putting the audio amplifier back in, the power supply back in properly. They've had a bit of a go at it, and looks like they couldn't fix it. But yeah, see how we go. So basically we've got our power supply, main power supply, and this another cable going to there. So I'd say that's my main input there. So we'll start measuring some voltages. It's a pretty old tight fit. Start measuring some voltages and see what I can come up with. I'll just adjust this camera up a little bit better. Now we can have a little bit of a squeeze, see what's going on. Okay, so we've got power, it's powered up. And I'm just going to check the power on the red and black cable coming out of this power supply box here. So, and we've got 20 volts. So we have got 20 volts coming in. So the power supply, that power side of that part of the power supply is working. Have we got power getting up to our main board via this flex cable? What have we got here? We've got another connector there, which runs up. That's a USB. And we've got 1.5 volts going up to there. Okay. Has got a fuse here, and we've got 16 on one side, and 16 on the other, so fuse is okay. So we're up at the dilemma of main board, no power getting to the main board. So might go and change this camera lens so I get a better view for you. Okay, welcome back. I've got this Milwaukee Radio. Sorry, pardon me. I've got this Milwaukee Radio. Now I've completely pulled out the tray up at the top, and I've unsoldered. I have unsoldered the antenna for the radio, which enables me to let this board loose. Now what I have done, I've actually unplugged this connector here, and I've got a meter, and I've just made sure that the power switch is working, and it's red and short when I press a button in, so the power switch is working. And I can't see anything obvious burnt on this. Missing a couple of little screws out of here would have been handy. So what I'm going to do is still not turning on, so what I'm going to do, I have checked and it has got power getting up. Alright, I'll just plug this back in. Plug this back in. Okay, so we're just checking power up to this board here, and there is power getting to it because I've already checked it before, but we'll just go from earth up here, just going from earth up on this connector here, alright, the black cable. Okay. Just fix this camera up a bit and go over there. Okay, so I'm just going from earth and we have got power. We've got the multimeter here. Now I have got voltage 10 volts, right? 10 volts getting up to the power switch connector here. We know the power switch is working. We know we have got power getting up to here. All this here will be radio circuit. This is your main CPU, which is a controller for your on-off. Receives an input. There's a little crystal here for a little bus, okay, oscillator bus here. Which is a timing crystal for timing for the chip, and it relies on an input from here to get the thing booted up. Okay, so what I'm going to do is power this off. Now, with my time fixing VCRs, thousands of VCRs and audio and hi-fi over the years, I have found that glue, especially the brown glue, can become conductive. So I'm just going to put a little bit of contact cleaner on there, and a little bit of alcohol. I'm just going to clean all that glue off. It becomes conductive. A bit more glue up here. Especially the yellow glue. Done thousands of VCRs, not thousands but hundreds of VCRs, audio, etc. with miscellaneous faults caused by the glue. It's okay when it's first put on there, then after it gets hard, it becomes like a capacitor. Especially that yellow glue. I'm just going to clean up all this old adhesive. They put the glue in there to stop the crystal from moving around and breaking its legs off. This is the most common problem in a lot of audio product. When you see that glue, just remove it. Okay, let's see what happens now. Can we be lucky? Now I'm going to remove the jack for the audio. Now, but also glued all those. Stop the connectors coming out. Which also stops me pulling it in out. Like so. That's better. That's better. Okay, so glue's not going to matter, but it's mainly glue on legs of CPUs. Okay. So the CPU is probably trying to get an input, and it can't because it's already got its legs all tied together with this adhesive, and therefore it can't receive an input because it's got like capacitors all over its legs caused by the glue. So you can go looking for a fault in here. Right, my number one thing would be the CPU, but with the glue there, I'd take the glue off first, but you can look for forever in a month for Sundays trying to find a fault with this thing, and you might find it's just there's no fault, it's just a glue. So now we're just going to hopefully, like so, and already nothing. Oops. There you go. What the heck is? Come on. Not there yet. What have we got here? Power. USB. Not on yet. How come we got that running like that? Okay, I'm back with this beast. Now, I've had a little bit of development with it. I've completely pulled the power supply out because I thought it might have been a power supply problem. And I'll tell you why I thought that in a sec. And I've actually completely pulled the volume pot, the power switch out. I've got that dangling here. I noticed the clock came on all of a sudden, but it was going on and off, on and off. And I noticed whoever done the repair last time had ripped one of these pins of this flex cable. So what I've done is soldered an extra wire in to make up for that broken track. Okay, the leg was broken on the track was broken on this flex cable, so I've had to put a link of wire in. So anyway, I had a bit of a development. Basically, I was measuring voltages. And I worked out that the CPU, this CPU, I worked on what turns these backlights on. Right, the backlight, the display lights for the LCD. The LCD is working, but no backlight, and what controls that is the CPU. So I went from the earth, this pin right here, which is the earth, from the power supply, up to this light circuit, and there's 2.9 volts on one side, and 2.9 on the other. And I'll just reverse these around, and then nothing on, there's 0.7 volts on the earth. So basically what this was doing, the CPU turns on when you put the power switch on, and switches through this transistor and puts an earth. I can prove it by actually earthing out no, it won't prove it. Now what I've noticed is I've checked the switch. Turn it on. Okay. Clock's flashing. Okay. So I can prove it by I'm just checking the voltages on this light. We've got 10 volts on there and 8 volts on the secondary. On the earth. Basically there is no earth. The earth is not connected. So the CPU drives the transistor which adds the earth. So the backlight for the display always has 15 volts on the positive, but then it adds the earth, connects the earth. Instead of switching the positive, it switches the earth to earth, and then the lights come on. Now I can prove that by shorting these two probes together, and you can see the display there. See? It lights up. Okay, so basically the CPU switches the earth. So basically when I'm turning this switch on, CPU, the inputs here goes to this CPU, drives this transistor, which turns the lights on. But all that's not working. Why isn't that working? So what I've found is when I measure the voltages on this switch, 7 volts, 10 volts. Now I noticed that when I was pressing the switch on, that this voltage was just fluctuating. It's going up and down, up and down, up and down. And it was almost if, when the voltages fluctuate like that to reference the earth, it's almost if there is no earth. From my previous experience with repairs on VCR, stereo, hi-fi, audio equipment, TV, televisions, game consoles, it seemed to be a voltage problem, and that's why I pulled this power supply apart, to get right to the crux of the matter and just check. So input voltage was 21 volts, 20 volts, 7 volts, and 1.5, right, which I wrote down on a piece of paper. But I found that even these voltages were fluctuating, okay, every time I went to measure a voltage, and then I found that this clock was going on and off, and I thought it was because of the break in this flex, but it wasn't. So I went back to basics, and I started back to this power supply and ascertained that this power supply is working, all the voltage is there, but it's not getting up to this board. But if that clock is working, it must have an earth. There must be an earth there somewhere. So what I did was this connector here, there must be an earth on that pin. There must be an earth, okay, for that clock to work. if it's a little bit above earth, alright, it's not earth, and I've got a voltage on it, but I've got another voltage that's higher than it, it still means that's close to earth, therefore we're going to get a result. And that's why that clock was working. So, what I've done is, I've gone back to basics, I've gone from earth and made sure there's an earth, proper earth, getting up to this board. And I've gone on every one of these pins here with my ohms, and I could not find an earth. So I've gone back to basics. I'm going to switch the power off, because I had to turn my camera off because it just got too complicated to record and track it through. But I went back over to the earth, and you notice I've scratched some coppers away. I'll just zoom in. Anyway, so what I did, I made sure I have an earth on that top board. A dead earth, not a virtual earth. And I've measured from each of these pins here to my main earth of my power supply. And when I measured, none of these were at earth. Okay? They all read resistance. And what I found is there was a fine hairline crack running through these tracks. 1, 2, 3 tracks. Maybe 4 tracks. So the earth was actually, that earth running up to here, right, was open. Okay. It was open. So I got my trusty. So what I might do is just bridge that out. That clock's still flashing because it's still got power in the power supply, even though the power supply is turned off. So what I'm going to do is bridge out those tracks. And just to be safe on the safe side, I'm going to unplug that power supply. So the radio's had a good drop. That's running with no power at the moment. That's just surplus power that's running through the board. See, it's not even connected. Not even connected. Clock's still running. Look at that. Okay. That'll turn off eventually once it my surplus capacitor die out. Charge, discharge it. Anyway, we're just going to bridge all these out. Yeah, so just when I was measuring voltages, the voltages kept varying. It's just fluctuating up and down and all over the place. And even when I pressed and held this power button in and left my multimeter on there, it then kept changing. So that tells you it's an earthing problem, an earth problem. See how my clock stopped now? Now that capacitors, those clocks run on really low current. They can run for ages. So I'm just going to bridge those out with wire. If I just solder them, they could break again, and I'm not fussy on pulling this whole radio apart again. Okay. I'm just going to make sure that the last one's intact. There's a fine break in that too. So I'm just going to put a bit of wire on that too. So you can't be caught looking for a fault in electronics devices. It's probably number one rule possibly would be to make sure the earth is actually at earth, not floating earth. So we're right to go there, and then the whole thing's come out. They glue these sockets in. Now, baby! And turn him on. She's on. She's a goer. So now I've just got to assemble this thing. There's about 100,000 pieces here. Yeah. So I'll just get this thing assembled and then I'll be back with the finalisation. Thank you. I cut a couple of wires here. Power supply when I was measuring voltages. I'm just gonna Just fixing a couple of wires up here. What I did, I cut these wires and I injected my own power supply in on those points to see if I could get it to kick up, so just to confirm it was power supply or not. Like so. Now, what have we got? Got those screws in there, got that. Okay, I've got these side pieces to go back in. These here. That could be the other side. No, it's not. Oh, what I'm looking for, squirrel screwdriver. Rightio, gonna get this other handle in here. I think it's had a major drop, this device. What looks of him. Yeah, she's got a crack running right. She's had a major drop. Got a dirty big crack running right through her. Through the housing, so I reckon that's where I should have sort of put two and two together there. But you know, it was cracked by whoever tried to fix it, or whether it was already cracked. Okay, so that's the two handles in. A major crack run. Major old cracker running around through there. Okay, so I've got that back into position. That pin there, so that pin there, that end is that end there, so I've just got to solder that under there. Okay, so I'm just soldering that wire on because one of these legs was broken. So just bypassing that. I think it was done by a previous repairer, so-called repairer, or someone tried to repair it. Okay, so that's back in there. Like, yay. Yay. Yay, and these are going to go back down in there. Like so, and go get this. What we're going to do, we're going to unplug those two there, and get this back into position there. And that thing there goes down into there. That goes down to there. Goes down to there. So it does it. Hang on. Up there. Well, that went that side. I don't know how it went. It goes up in there like that. Okay. Now who's taken all this? Someone's taken half of the screws out of here. Trying to fix it. Okay, that's right, that opens up and it's got to go into there. Like so. And we've got Gary here. That's me pot there. And put that into there. This here goes on an angle like that. taken all half my washers out. No. Like so. Now, where have they ripped that antenna off? Okay, that's your speakers. That's your audio. That's that there fixed up. I'll just put that under there. Out of the way. Get that down into there. They pulled this off here, which is the FM antenna. Which is out of this plug connector here. Okay, goes on there. Yeah, I don't know which one is which, so we're just gonna see whether these two are shorted. So we've got a short across these two. Yeah, we have, so it doesn't really matter which one it goes on. Okay, so now I've got to get this panel here in. The right antenna, ferrite antenna. It goes in that way. Like so. I've got that one there, which runs down to there. And we've got our antenna, AM antenna cable there. Antenna there. We've got two, which I'm going to go. 1, 2 LED. So that's not that one. Where did they run from? That's the FM antenna. FM antenna, are we missing a connector somewhere? Is it under there? That's one of them. Must be underneath. That's one of them. Oh no, hang on. That one goes in there. Okay, that's those ones. Now, all I have to do is put the AM antenna back on. Okay, so I've just put the AM, soldered the AM antenna wires back on, got all these wiring looms back in. Like so. They've got the FM antenna there to go in, which is just pulled out of there. Someone's pulled it out of there, so make sure it's the right way around so it goes. Like so. Okay, now I never took how many screws I've got. That's all those screws for that. So that's all intact. Yeah, so I've got this Milwaukee Radio completely finished. I've reassembled it all. It takes a bit of pulling apart. You've got to pull these side panels off here, all your screws, take the whole thing, pull it right down. But ended up being a floating earth, and there was a broken track on the board. So it looks like it's had this particular unit's had a bit of a hit. And it can be tricky finding when you've got to cook earth. It can be tricky because the voltages seem to be there and they're floating up and down and all over the place. And so make sure your main earth is connected to your sub earth and to your main board earth. Make sure they're all really short, because if you've got a crack in that sort of floating earth, you can end up with trying to find a difficult fault. So I narrowed it down by mimicking the on-off control, and by actually putting my own earth on there, and then going back and realising that it was a floating earth and there was a break on the board. So yeah, so that's what we did. I'm sorry I couldn't do the whole video because it got a bit complicated. I ended up having to stop the video, and I spent probably another hour and a half getting to this point at least. So thanks for watching, and please subscribe and have a nice day. Thank you.